So all of you are aware of DMAC methodology? DMAC.
Yeah.
Come on, please. Yeah.
Okay.
Yes, you are aware of it. Otherwise, you cannot be a green belt. You cannot be, yeah, Six Sigma belt. You are aware of it, right? Define, measure, analyze, improve, and control. So when can we use this DMAC? Because there are many other methodologies also available. In different industries, use different method. A3, PDCA, 8D, QC story. And there can be, some other methods unknown to us. But in what way the DMAC is different? Can any of you answer this question? It can be an interview question. Way DMAC is different.
In DMAC, we are investing more time on analyze and measure compared to PDC and
Very
other
good.
tools.
Very good. We invest more time in measure and analyze. Very good. That means our approach is data driven. That is what you mean to say, isn't it? Our approach is data driven.
Yes.
So, and moreover, see, the direct answer to my question is DMAC methodology will be appropriate if the problem is very complex. If the problem in hand is complex in nature, right? So complex in the
Yeah.
sense, one is, it is recurring. Another thing is root causes are unknown, right? So you can't solve a problem no, just with your engineering knowledge. You can't solve the problem just with your experience. Those kind of problems can certainly be solved using the MAC methodology. Okay. All right. So coming to the define phase, you all know the outcome of define phase is problem
Problem
understanding,
statement.
problem understanding, problem statement, process understanding, process.
Yes.
Whatever be the project, you have to express it as a process improvement project, and that within the, and that process must be that process must be just a second. That process must be visualized. Process steps must be spelled out, and within the process steps, the defect origination point you must have a clarity. Defect origination point. What is the point after which only the defect originates? Will you be able to figure out this, all of you, in any problem when you are solving? Process means number of steps. Let's say there are 10 steps. Which step is actually triggering the defect? Will you be able to underline the step or the process that is triggering the defect? Yes or no, all of you, you can do a Gemba if required. You can go for
Yeah.
what do you call? The visit to the process where, the
Gemba.
place where,
Gemba.
visit to the workplace. You can have enough observation. You can collect data, all that you do it. But ultimately, you should be able to find out the defect origination point. If defect is getting originated from a particular point, where is it getting detected? Defect origination, another thing is defect detection. If these 2 points are understood, then all the steps that are happening inside these 2 steps are in the scope of your project, your investigation, and all that will be happening. Do you understand, all of you?
Yes, sir.
Yes. So that's very, very important. So we need to have a clarity, and this is what is defined phase. In defined phase, the project charter is approved, problem is understood, process is identified, defect origination is understood, defect detection is understood, whether detection is a problem or the occurrence of the problem is the issue, and accordingly we will be taking the corrective action and preventive action. But however, once the project charter is approved by the management, your define phase is over, then you can proceed with the measure phase. In the measure phase, the what do you call? In the measure phase, our objective is to validate the problem. Validate the problem. And if you say you are doing a project, you will certainly have a metric that needs to be improved. Yes or no? A metric of improvement. We call it, the project Y. That project Y, now you have to verify or validate with the help of data. Let us say your project is, reducing the turnaround time. Reducing the turnaround time of a process. Let's say the current turnaround time is 43 minutes. Our objective, our target is to bring the turnaround time below 30 minutes. Now, how do you say it is 43 minutes? Do you have any data backing up your understanding? Right? Do you know? You can actually visualize the TAT, let's say for 30 days or last, 90 days or whatever be the period possible. You can actually visualize the TAT for the last 30 days. And this is now called a kind of run chart. What is run chart? Day number 1, day number 2, day number 3, day 4, and 30 days. And every day there is a TAT available. The time in a particular sequence is taken in the x-axis, and the y variable is monitored with respect to each of the x. So we have a kind of chart, and from the chart, if the process is approximately stable, then you can summarize. You can conclude that yes, the current TAT is 43 minutes. So this is called what? Baseline. And when you are actually collecting the data, and your data should be free from any error, and so and if you have any doubt about the measurement system, then we have a MSA procedure, measurement system analysis. For measurable data, there is a gauge R&R study possible, and for attribute data, there is a AAA study possible. AAA means attribute agreement analysis, and we are going to learn AAA today, right? Because gauge R&R we already discussed, and now the AAA we will be discussing today. So if the AAA study and gauge R&R study, whatever is applicable, if that gives a green signal and your data is found to be credible and worthy for analysis, and so you can actually collect the data and conclude on the current state, which is the baseline, right? And if the baseline is done, the measure phase is over. Then you move on to analyze phase. In analyze phase, we studied about some basic tools like brainstorming, fishbone analysis, impact control matrix, and any kind of prioritization tool. The prioritization tool will help us to separate the most likely causes. Do you know what are most likely causes? Through judgment, through engineering logic, through brainstorming, we have separated certain causes as the most likely root causes. That means our suspect is strong, and logically also those factors are found to be there, are expected to be the root causes. The only thing pending is some proof has to be, provided. That's all. We'll conduct some experiment. And get our doubt validated. If your validation also gives a green signal, then the most likely root cause can be declared as validated root cause or verified root cause. What do I mean by green signal? All of you, can one of you tell me? The most likely root cause is subjected to some experimental verification. And getting a green signal, what is the tool you will be using to understand whether the signal is green or red? Red means your doubt is wrong, right? So green means, okay, your doubt is correct. And so you can actually declare the factor as root cause and you can actually take action. So what is the tool you can use to understand whether the factor is critical or not? What is the tool? Come on, you cannot keep quiet. During the experiment. Yes. Come on, Ajit.
அதான் சார் பிஎம்சி ஷீட் ஓபன்
What is the sheet?
PMC, process monitoring chart.
Okay, process monitoring chart is something you follow in your company, right?
Yes, sir.
That you continue following and will not be able to follow. And we all studied a tool called p-value. We all have studied a tool because all the experimental data, experimental findings will be considered valid only if p-value is how much? P-value is above 5% or below 5%.
Below 5%.
Below 5%.
5%, sir.
Check whether the p-value is below 5%. If that happens, then then the factor is considered to be the root cause, and then we can think about kappa. What is kappa?
Corrective and preventive action. Corrective action and preventive action.
Corrective action and preventive action. What are you supposed to do in corrective action and preventive action?
சார் கம்ப்ளைண்ட் வந்த உடனே வந்து கரெக்டிவ் ஆக்ஷன் எடுப்போம் சார். ஐசிஐ பண்ணுவாங்க அது கரெக்டிவ் ஆக்ஷன். ப்ரிவென்டிவ் ஆக்ஷனா இனிமேல் வராமல் இருக்க ஒரு சொல்யூஷன் கண்டுபிடிச்ச கூடாது.
Poca yoke, sir. Preventing method.
Okay. See, as soon as you receive the complaint, immediately you can't take corrective action. You can only do some correction. Corrective action requires some analysis, root cause identification, all those things. But correction you can do immediately. Your vehicle, is there was a breakdown all of a sudden on the road. Can you take corrective action immediately? But you have to reach your office. It's an urgent meeting. You have to reach your office. So what will you do? You will book a cab. Booking a cab is corrective action or correction? Booking a cab is corrective action, is it? Problem is still there. Your old car is now still lying on the road only. You are only booking a cab so that you can reach the meeting on the spot. You don't want the problem to proceed to the next stage, isn't it? You don't want the problem to proceed to the next stage. Otherwise, it will aggravate, isn't it? Your absence, will then be questioned and something else can go wrong. There are many other consequences. This is called quarantine, isn't it? Containment. This is called what? Problem containment. So problem containment is correction. That you can do immediately. But permanent corrective action requires root cause analysis. Permanent corrective action requires root cause analysis. And that is what we performed in the, in the analysis phase. So after thorough analysis, after understanding about the root cause, you can actually generate the solution and you can implement the solution. All of these things will be part of your improve phase. And then in the control phase, some of you told correctly, Pokai, okay. You can add Pokai, okay. You can start monitoring certain metrics, certain indicators, which can help you identify the failure even before the failure can happen. Do you understand my point? You identify certain metrics, and those metrics are so powerful that even before the failure can happen, the metrics will give a clue. Something wrong is going to happen in the very short, near future. So you can take, preventive action. So such metrics are called leading indicators. Such metrics are called leading indicator. There is no point of, taking action always after the failure has occurred. If you could develop some knowledge so that you could identify the failure before the occurrence of the failure. They are called what? Leading indicator. Are you with me, all of you? And all these leading indicators should become, part of your control plan. And those leading indicators should be monitored on a daily basis, daily work management. If your people are monitoring those leading indicators, and now the problem is permanently prevented. This is called preventive action. Are you with me, all of you? Define, measure, analyze, improve, and control.
Yes.
Okay. All others, I think weekend, now heavy lunch and listening to me, I think you're finding it difficult. I understand, but still participation is important. Okay. So you continue interacting with me. Either you should speak or you can answer in the chat, right? Okay. So yes, you can also use the reactions. So now we will get into our today's scheduled topic. Can you tell me what are the topics we have planned for the day?
CPCPK
CPCPK,
process
PPPK. Very good.
PPPK.
So I will quickly help you understand. So we already learnt about CPCPK, right? How are they called? First of all, CPCPK. Again, this is an interview chapter. Definitely,
Process capability index.
yeah, they are called. One is CP, another one is CPK. CP should be called as potential process capability ratio, PPCR. Potential process capability ratio. Another one is CPK, process capability index. We already studied this. I have explained this. Potential probability process capability ratio means USL minus LSL divided by
6 sigma.
6 sigma, where the sigma is nothing but the variation found within your subgroup.
Specification.
Variation found within your subgroup. What is the formula for the calculation of the sigma when you are talking about CPCPK? What is the formula you should use?
1.37, 1.67 minimum.
No, that is the value, expected value.
R by D2. Yeah.
R bar by D2. Very good. I'm sharing, the screen now. Okay.
R bar.
Yes. Yeah. R bar by D2. CP is USL minus LSL divided by 6 sigma. And I hope you all know why am I writing yes, right? I'm not writing sigma, I'm writing yes because the data I have is sample.
Simple.
And the formula for yes is R bar by
D2.
D2. This is called within standard deviation. This standard deviation represents the variation within the subgroup. This represents the variation within the subgroup. Okay. And when we come to CPK, what is the formula we have studied already? Minimum of
CP upper and CP lower.
CP lower.
So what is the CP upper, CP lower? Any guess?
Upper significant limit minus X bar divided by 3 sigma.
Okay, I'll make this concept very simple. So let me erase all of this. See, there are two things for process capability. One is variation, another one is center. Right? So customer has given USL, LSL. There is USL and there is LSL. And in the center is what? The target. Now one thing is process variation. The whole spread of your process. Look here, the spread of your process. The spread is normally considered as 6 sigma, right?
Yes.
The whole spread of the process you should be able to accommodate within USL and LSL. That means the variation is important. The size of the car and the size of the parking area. What is this? Size of the parking area. But what is this? Size of the car. Now the question is whether the car will go inside the parking area or not. And looking at the picture on my screen, you can easily understand, yes, the car can go inside the parking area, yes or no? There is a parking area and there is a car. Can this car go inside?
Yes.
Yes.
Definitely go inside, right? Because the parking area width is USL minus LSL and the car width is, 6 sigma. Whenever the 6 sigma is smaller, whenever the car size is smaller than the parking area, car can go inside. In all these scenario, CP will be more than 1. Yes or no? When the car is smaller than the parking area or 6 sigma is smaller than USL minus LSL, the ratio will be more than 1. Do you understand? Do you agree, all of you?
Yes.
Yeah.
Potentially capable.
Yes.
This is the condition called potential capability. Your car is still outside only. It's still standing on the road only. It doesn't enter the parking area. But definitely car can go inside. For the car to go inside, what are you supposed to do? You have to start the car. You have to drive it and take it inside the parking area. Yes or no?
Yes.
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 But for driving the car and and take it inside the parking area, you need a driver.
Driver, skilled driver.
Once you also appoint the driver, and if the driver also demonstrates the right capability, then then you can be confirmed about your capability. Yes, I can park my car safely every time. Not just once. The parking area and the car and the driver and everything is appropriate in relation to each other, right? And that means I am very confident that all 365 days in a year, I will park my car without any accidents, without any kind of scratch or something. The process is now capable, which means when the driver is driving the car, you just have to study his tendency of doing a wrong driving. What is doing a wrong driving? If he drives perfectly in the center, the driving is, very, I would say again, it's a perfect driving. But if you shift to the right or if you shift to the left, the risk of hitting the walls will increase. Do you understand?
Yes.
Understand, sir.
So process shift, is there any shift? You have to check. What is shift? X bar minus mu is the shift. X bar minus mu is the shift. What is X bar?
Average.
The process center, the center of your car.
Mean value.
What is mu? Mu is the customer
Mean of
given
the
target. The process average and customer given data. Customer given target. Customer given target is mostly the midpoint of USL and ASL, US and LSL. If there is no difference between X bar and mu, then what will be the value of X bar minus mu? Tell me. If X bar is equal to mu, tell me what will be X bar minus mu?
Yeah. This is process is controlled
0.
towards center. No shift is there.
Yes. So whenever X bar minus mu is 0, there is no shift. Whenever X bar and mu are different, in such a
shift is
case,
there.
there is a shift. If the shift is right side, then the risk of hitting the wall on the right side is higher. If it shifts on the left side, then the risk of hitting the wall on the left side is higher. So now, imagine your process is shifted. There is LSL, there is USL. There is USL, there is LSL. Your X bar is supposed to be here, but actually it has come here. Now, still how much tolerance you have? You only have a little. And this little area is called USL minus X bar. Do you understand, all of you?
Understand, sir.
Yeah.
If your process is exactly here, then the distance between your process center and USL will be the full value. And this right side value, and similarly, there will be a tolerance on the left side. They will be equal if the process do not experience any shift. Do you understand this statement? If there is no shift, if the driver is exactly driving the car at the center, then the distance to the right side wall, distance to the left side wall are equal. Yes or no?
Equal. Yes.
If they are equal, you don't have to calculate CPK. The CPK will simply be equal to CP. Are you with me?
Yes.
If the driver is doing his
Yes.
job perfectly, you don't have to doubt him further. He is driving at the center, then whatever you expected, with the CP, the same will be the value for CPK. But if the process undergoes a shift, then in such a case, CPK will be different from CP. Do you understand?
Yeah.
Then only you should calculate CPK. Otherwise, no need to calculate CPK. How to calculate CPK? I'll tell you. And now, CPK, you just have to check whether the shift is to the right side or left side. Imagine the shift is right side. Then that's in such a case, you must calculate only CP upper. When to calculate CP
Yes.
upper? The process is shifted to the right side.
Right, sir.
Right. Sir. Yes.
Imagine that the driver have a tendency to shift leftwards. In such a case, CPK will be
Left
equal
side.
to CP
Lower
lower.
side.
Now, we just have to understand how to calculate the CP upper and CP lower. After calculating, we have to check whether the process is shifting to the right side or left side. If it shifts right side, then CP upper will be equal to CPK. If it shifts left
Yes.
side, then CP lower will be equal to CPK. All of you are clear with me up to this?
Yes.
You are
Yes,
following?
sir.
Yes, sir.
Yes. Now,
Yeah.
there is USL, there is LSL. There is USL, there is LSL. And customer target is 100. USL is 100.5 and LSL is 99.5. Now, customer tolerance is understood? 100 plus or minus 0.5?
Yes.
Yes, sir.
Yes. Now, my process is operating like this. My process center, I'm telling you, X bar. 100.2. Now, please tell me, is this process shifted right side or shifted left side?
Left side.
Right.
Right side.
Left side.
Process is shifted
Left side.
right side. You see here, the shifting is towards right. It is moving towards the right side wall, isn't it? Am I right?
Mm.
Yes.
Shifting, the process
Yes.
is shifting towards right. If the process is shifting towards right, then CPK will be equal to what? CP?
Upper.
CP upper.
Very good. CP upper. You don't even have to calculate CP lower in this case, right? You only have to calculate CP upper. And now, how to calculate this CP? Oh God. How to calculate this? Okay, 100.2, right? So how to calculate this CP upper? Now, you have to find out the difference between the upper spec and your process average. Upper spec is USL. Upper spec is USL. Process average is X bar. Are you seeing it on my screen? The difference between upper spec and process average. Why am I taking upper spec? Can somebody answer me? Why not lower spec here?
Process
Process.
shifting to right.
Process is
Come on, you are right.
shifting to the right.
Process is
Shifting to the right.
right. If it is shifting to the right, I will obviously check the distance of my process center with the upper spec. So upper spec is taken, process average is taken. The difference, I want this difference to be maximum. As the difference decreases, my process may start operating outside the specification. So this is the numerator and denominator will be 3 sigma. Why the denominator is 3 sigma? Because now I have taken only one side, isn't it? Only the upper spec is under risk, not the lower spec. If I want to consider both the specification, then the spread of the process should be taken as how much? 6 sigma or 6s. But now it is only 3s. So this is how you should calculate CPK. CPK will be equal to CP upper the moment you understand the process is shifting rightwards. And CPK needs to be calculated only if the process shifts. If the process do not have any tendency of shifting, it is operating right on the target. Operating right on the target means X bar will be equal to mu. In this case, CP will be equal to CPK.
CP upper.
You don't need to calculate them separately. Just calculate any one. You calculate CP, you calculate CP upper, you calculate CP lower. All of them will be equal. When this is true,
Bar equal to mu.
it's an interview question. All of you will get a promotion, right? If you answer this question. So, when the CP will be equal to CPK, and when the CPK will be equal to CP upper or CP lower, all of them will be same. CP equal to
When there is no
CPK
shift.
equal to CP upper equal to CP lower. All of them are same value. When this will
Laga
happen?
If the target is achieved and there
If
is
the
no shift,
process
it
is
doesn't have
centered
any
on
shift.
target. If the process is centered on target. So what do I mean by process centered on target?
Mean.
You have to visualize yourself. You have to
Adequate
visualize
space
LSL.
given on the left and right, that is lower and the upper spec.
Exactly. So I give another example to all of you. Right? I'm saying 50, 53, 47. Now tell me what this is customer specification. Now what is the customer given target?
Plus or minus
50 microns or 50. And what is the upper spec given by customer? 53.
3.
Lower spec given by the customer is 47.
This one.
That means the tolerance is plus or minus 3 microns. Now imagine you have taken 10 samples. And from the 10 samples, you are calculating an average. Now, average can be exactly equal to 50. Average can be more than 50. Please understand.
Yeah,
Average can be
even less than
exactly equal to 50. Average can be more than 50. And average can be less than 50. Am I right?
Yes.
Now tell me,
Yes.
let us take the first situation, first condition. Average is equal to target. Now, in this case, you just have to relate CP, CP
Equal to
upper,
CPK.
CP lower, and CPK. Now, what is the symbol I should use here?
Equal.
All of them will be equal. You don't have to calculate so many things to judge the capability. Calculate any one. Are you with me, all of you?
Yes, sir.
Yeah.
If there is no shift, CP will be equal to CP upper will be equal to CP lower will be equal to CPK. Calculate any one and that will be the thing. I think the one that can be calculated easily is USL minus LSL divided by 6S. This is the formula. You don't have to change the formula. But the formula may change. Suppose if this condition is violated. Let's say this is the situation. If this is the situation, your X bar may be, let us say, 51. Now, what is the condition? X bar is more than 50 or less than 50?
More than
more than 50.
More than 50. Now, all these conditions will be violated. Now, CP will be different. CPK will be different. Do you agree with me, all of you?
Yes.
CP will be different. And for calculation of CPK, you just have to calculate CP upper. Lower is not required. You know why? Process is shifted rightwards. So CP upper, what is the formula? We have to take the distance between upper spec and our process average and divide that by 3 times standard deviation.
3 times. Yes.
Standard deviation.
3 times standard deviation. And this standard deviation, I already told you during the CP-CPK discussion, the formula for standard deviation is R bar by D2, remember. Now, one of
Sir, can you repeat the
have,
formula?
see CP upper, it is here, formula. distance between nearest spec. The nearest spec is USL and the process average, which is X bar, divided by 3 times standard deviation. And this standard deviation is, formula should be R bar by D2. And this is called within standard deviation, variation within the subgroup, variation within your sample set. You have taken a set of 10 samples. There could be a variation within the 10. That is called within variation. How to quantify that? R bar by D2. So use that formula. CP upper is obtained and CP upper will be equal to CPK. Now I want all of you to answer me. If this is the situation, what is the situation? CP upper is calculated and assigned to CPK. Now what will be the relationship between CP and CPK? Are you sure, all of you? CP and CPK,
Not
they are
equal.
not equal.
Yes.
And out of the two, CP and CPK, which will be larger and which will be smaller?
CPK will be larger.
CPK
sir.
will be larger.
CP is smallest. CPK is
CPK will always be smaller than CP only. Max to max, it can become equal.
yes, sir.
Max to max, it can become equal. If the moment a shift happens, CPK will start dropping. So, if you want to specifically write, CPK is smaller than CP. Are you with me, all of you? Whenever there is a shift, your CPK will immediately drop. It can be shifting to the right or it can be shifting to the left. But if you want to generically say, you can say they are not equal. If you want to specifically mention the relationship, then you should use the lesser than symbol. Are you with me, all of you?
Yes.
Yes, sir.
Clear?
Yeah.
Okay. Now I am telling you X bar equal to 49 point. Okay, X bar is equal to 49. Now tell me, when X bar equal to 49, process is shifted or not?
Yes.
Shifted.
Yes.
The left
Shifted.
side.
And tell me, shifted to the
Left side.
right or shifted to the left?
Left side.
Left side.
Left side.
Since there is a shift, I am writing the CPA is not equal to CPK. Whenever CP is not equal to CPK, I have to calculate both of them. What will be your formula for CP?
Lower.
Go for
X
lower.
bar minus
X bar minus lesser by 3, yes.
See, I am asked, just answer my question. What will be your formula for CP?
USL
CP.
minus
USL
LSL
minus LSL
USL minus
sigma.
LSL
Divided by
divided by
6 sigma or
6S.
6s. And
Yes.
sigma and s, you know the meaning, right? Very good. But for calculation of standard deviation, the formula to be used is R bar by D2.
Yes, sir.
Very good.
Yes.
And R bar is nothing but the center line in your R chart. D2
Yes.
is a constant that depends on your sample size. This much, all of us know. Now, CP is not equal to CPK. Now, specifically, your CPK will be smaller than CP or larger than CP?
small.
Smaller.
Oh.
Smaller. And I want to understand how much it is. So I want to understand how much it is. So I am going for the formula. And CPK will this time will be equal to CP lower. Am I right?
Yes, sir.
Yes, sir.
Mm-hmm.
And the CP lower, what is the formula I should use?
LSL minus X bar. Divided by 3
X
sigma.
bar minus
Don't write
LSL.
Minus
minus
LSL
X
by
bar.
3.
Yes.
So X
Write
bar
X bar
minus
minus
LSL.
LSL. Divided
Divided by
by
3 sample
3S.
size.
3S or 3
Yes.
sigma. Okay. This is the formula. I think now all of you have mastered this subject, CPCPK.
Yes, sir.
Will you be able to really apply this for any situation? But CPCPK discussion is required. CPCPK analysis is required if you are measuring the capability for measurable characteristics. Measurable characteristics. Let us say coating thickness. Can I calculate CPCPK? Yes. Diameter. Can I calculate CP/CPK?
Yes, sir.
Answer is yes. Concentricity. Can I calculate CP/CPK?
Yes, sir.
Yes. Surface finish. Can I calculate CP/CPK?
Yes,
Yes.
sir.
Turnaround time. CP/CPK I can calculate.
Calculate.
CP/CPK is because time is also measurable.
Measurable.
Also, please note whenever you have bilateral tolerance, you need to calculate both CP and CPK. Sometimes the tolerance may be unilateral. What is unilateral tolerance? The tolerance is given only on one side.
One side.
Say, for example, turnaround time must be less than 30 minutes. Whenever the turnaround time becomes more than 30 minutes, it's a defect. It's a failure. Customer is going to give a penalty. But anything below 30 minutes, it's not a problem. And in such a case, you only have to calculate CPK, no CP required. Do you understand, all of you? When do you require only CPK? When should you ignore CP? If you are working with unilateral tolerance. Are you with me, all of you? Correct? Yes.
Sir, can you please repeat?
Yeah. If the upper spec is critical,
Yeah.
then CPK will be equal to CP upper. If lower spec is critical, then CPK will be equal to CP lower. For example, your exam mark, all of you. What is the pass mark?
35. 60%.
That is your school mechanism, school 60 here, right? So 60%. So if you score below 60, then it will be a failure. You will be asked to reappear, right? And all those complications. But if you score more than 60, it's not a problem. You can go, up to maximum possible. You can go even score 100 out of 100. But if you come below, then it is critical. In such kind of scenarios, unilateral tolerance, but which side is critical? Left side is critical. In those cases, you have to calculate CPK, and CPK will be equal to what? CP lower.
Lower.
The capability analysis is now over. Please tell me, will you be able to apply this knowledge for estimating the process capability in your workplace? Will you be able to apply, all of you?
Yes, sir.
Yes, sir. Yes, sir.
What is that you should check? First of all, you should check whether the characteristics under discussion is measurable. If the characteristics under discussion is measurable, then only CP/CPK comes into picture. Otherwise, no. Okay. Now, capability is understood. CP/CPK is understood. All possible scenarios we discussed. Even though it's a complex topic, I believe you will still be able to discuss with anybody with a lot of clarity when they talk to you about CP/CPK. Is my understanding correct?
Yes.
If this is going to be true, you will definitely be selected in the interview. True. If we say you are a Six Sigma belt, and if the discussion goes in this direction, and you demonstrate this kind of clarity, what will happen? All the possibilities. There are only two things. One is shift, other one is variation. If there is no shift, what is coming to your mind?
There is no variation.
CPK is equal to CP.
CP is equal to
CP
CPK.
will be equal to CPK. If there is no shift, CP will be equal to CPK. But if there is a shift, CP will
Then
be
lower-
not equal to CPK.
Not
CP and
equal to
CPK will be
CPK.
unequal. And always CPK will be smaller than CP.
CP.
CPK
Or
will
equal.
always be smaller than CP. Very good. And if the process is shifting rightwards, then CPK will be equal to CP upper. If the process is shifting leftwards, then CPK will be equal to
Lower.
CP lower.
CP lower. What is the formula for CP lower?
LSL minus X bar divided by
LSL minus X bar divided by 3S.
Don't say LSL minus X bar, because LSL will be on the left extreme. Your X bar will be
X bar
inside.
minus
So
LSL.
you have to say X bar minus LSL. Okay. So otherwise your CPK will become negative value. And that is, very, that means, the process is under a very dangerous shape. The entire process is operating outside the specification limit given by the customer. That's a rare scenario. In those cases, CPK will become negative, right? And then only the, yeah. But in any case, you have to use X bar minus LSL. But when you calculate CP upper, you have to use the formula USL minus X bar divided by 3S. And also please tell me one last time, how will you calculate the standard deviation while estimating CP/CPK? What is the formula you should use for calculation of standard deviation?
R by D2.
R
D2.
by D2.
R bar by D2.
R by D2 or R bar by D2?
R bar by
R
D2.
bar by
R
D2.
bar by D2.
Very important. R bar by D2.
Yes.
And D2 depends on
Sample
sample
size.
size or subgroup size. Now we understood everything about capability. There is one other metric, like your capability indices. In general, they are called as process capability indices. CP and CPK together, they are called as process capability indices. But there are another set of metrics called process performance indices. We are going to understand the difference between CP/CPK and PP/PPK. So what am I saying? There is capability indices which we discussed right now. In fact, already we learned. Today we just recalled. Yeah, 1 minute. So process. Okay.
So here capital P is for performance.
Capital P is
For performance.
I'll come to you. First, okay. See here, what is process capability indices? Indices, because there are two. We call it process capability indices. When you use the word index, then it becomes CPK. Indices, it's generic. Potential process capability ratio, then it is CP. Now I'm giving another thing. PPI. You know what is PPI?
Process performance indices.
Very good. Process performance indices. So they are specifically denoted as PP and PPK. Now we need to understand the difference between the two letters C and P, because other things remains common. You can easily understand from the symbol, isn't it? What is the difference? In the first one we have C, in the second one we have P, which means we are going to understand the difference between capability
And
and the other one
performance.
performance. Please tell me in plain English, are these two words are same or have different meaning?
Different meanings.
Words are given, that means definitely there must be a difference in the meaning.
Different.
So what is your understanding? Capability means what and performance means what?
Capability means capacity.
Capability means
Ability,
training,
sir.
This level 2
Ability.
is capability. Minimum maximum is
Ability, sir.
capability. Performance.
Which is actual here? Tell me, all of you, are you paid for your capability or are you paid for your performance in your company right now?
Performance.
Both, sir.
That is
Oh, very good. You are matching it. You already reached your ultimate. You already reached your ultimate, right? Okay. So during the interview, what do they understand? They assess your capability, isn't it?
Yes.
During the interview, they assess your capability. But after appointment, if you disappoint them,
Performance.
there is more chance that
It's
you
a
disappoint them, isn't it?
performance.
After the candidate is recruited, the chances are high that he can disappoint the recruiter, isn't it?
Yes, sir.
Yes.
Or he can fulfill the requirement. That means, performance max to max can be equal to capability. Yes or no? Performance is max to max can be equal to capability.
Capability.
So your performance indices maximum, they can become what? Equal to your capability indices. Are you with me, all of you, on this?
Understand.
PP, PPK maximum can be equal to CP, CPK. If somehow, if you make it happen, you are the best, in your job. For a particular process, if you make the PP, PPK equal to CP, CPK, and already you very well know your PPK and CPK should be more than how much? 1.67.
1.67.
So I assume you achieved 1.67 for CPK. You achieved 1.67 for PPK also. The max, you have achieved, the maximum potential. You understand, all of you?
Two.
Yeah. See, further, you see, if CPK is 1.67, then your PPK can maximum become 1.67 only. If your CPK is 2, then your PPK can also maximum become what? 2. And 1.67 and 2, there is no limit. It's only an industry guideline, AAG guideline, which demands 1.67 for critical characteristics. You want to make it 2, most welcome. You want to make it 3, it's up to you. When the CPK is 2, that is called the Six Sigma capability. I hope all of you are already aware of it, right?
Already updated.
When CPK becomes 2, then your Sigma level will be 6. Very good. And now coming to the PP and PPK, there is performance and there is capability. In other words, capability is, short term. Capability is short term, but performance is long term. Capability is short term, performance is long term. Imagine you have purchased a new machine. You have purchased a new machine and it is, just now commissioned and it is all set. And now the machine is performing extremely well. You know why? It is brand new and, there are minimal challenges. So what we estimated is the capability, isn't it? But do you think the machine will perform the same manner continuously for years together?
No.
After 6 months, there can be some wear and tear. It may give some lesser kind level of performance. Gradually, performance may deteriorate over time. Performance generally may deteriorate over time. All of you agree with me, right? For example, as time passes, right now you remember all the discussion, isn't it? If you suppose you sit in an interview tomorrow, you will be very happy discussing about CP and CPK because you just learned today. But if the interview happens, after let us say some 6 months, then the tendency is to forget. Yes or no? Similarly, the performance also tend to deteriorate over time. As you move from short term to long term, the PP and PPK will always differ from CP CPK with a lower value. First thing. And for short term, to assess the the variation, to study the variation, we used a formula R bar by D2, am I right? We used the formula R bar by D2 to understand the standard deviation. However, for long term, you need to use a different formula, not the R bar by D2. You need to use a different formula for calculating what? Calculating S. But this time, the S is called overall standard deviation. What is the standard deviation you should use for calculating PP and PPK? Overall standard deviation, not R bar by D2. R bar by D2 is called as within standard deviation. Now the formula for overall standard deviation I am writing here. Have you seen this formula already, all of you? Under root of summation of x minus x bar the whole square by n minus 1. Have you seen this formula, all of you? General formula, right? General formula of the standard deviation. If you use this formula, you will get a standard deviation called as overall standard deviation. Now, instead of using the within is here. Instead of using the within, if you use overall, then your formulas will deliver the values for PP and PPK. Do you understand my language, all of you? That means PP, the formula for PP is, I'm telling you, formula for PP is USL minus LSL, USL minus LSL divided by 6 times S, but the S must be what?
Overall standard
Overall. Do you
deviation.
understand, all of you? S must be overall. If you use within, you will get what? CP. If you use overall, you will get PP. Do you understand, all of you? Now, same logic. PPK will be equal to PP upper. PPK will be equal to PP upper. You know why? You know when? When the process is experiencing a shift rightwards. When the process is experiencing a shift leftwards, in such a case, PPK will be equal to
PP up lower.
PP lower. That's all. Now we are going to take an example and we are going to calculate CP. We are going to calculate CPK. We are going to calculate PP. We are going to calculate PPK and understand what's exactly the difference, in the calculation. Then, the PP, PPK is also understood. But in general, now we understood performance is different from capability. Imagine all of us want to participate in a singing competition. That will be nice, right? All of us participating in the same competition. Any singer here? No professional singer here, right? But all of us like singing. Is my understanding correct?
Yes, sir. Yes, sir.
Yes.
Can we have a demo now? Yeah, then that will be very dangerous, right? So performance is always difficult. But what do we think? No, we can sing with a what do you call melodious voice. That is our assumption. So so imagine we all wanted to go for a singing competition. So we all decide to practice. Tell me, how do we practice? Come on, all of you. All of you have to practice. All of us have to practice for 1 week. Now tell me, how do we practice?
We sing.
Yes, tell me.
We'll have to
By lyrics,
plan the location where we are practicing. We'll have
Yeah.
to set up the timings and take a list of participants who are going to sing in this competition.
All right.
Or
Yes, all of us are the competing members. We are competitor to each other, but we all decide to practice privately, right? So when we practice privately, what do? You take the choice, the lyric of your choice, whichever lyric you like, you choose, isn't it? And then you probably practice in a private room. No
yes,
judges,
yes,
no audience. That means you are trying to see your capability. You are trying to assess your capability. The environment is decided by you. It is not a real environment. Am I right? If the environment is decided by you, you are only assessing your capability. Similarly, when you measure, when you do a study in your workplace, if you decide, the entire environment, like you select the best parts, best operator, best raw material, you are only trying to estimate CPCPK. Do you understand? Right?
Yes.
But if you allow all the factors to influence, means, imagine, there is an audience of a stage with 1,000 audience. There are judges, 3 judges sitting on the left side, another 3 judges sitting on the right side. This is a real environment. Yes or no? Now so many factors will be influencing your performance. Am I right? When you are practicing in a private room, it is very easy to sing. But if 1,000 eyes are on you, then the influence will be huge. Yes or no?
Yes.
So this is called performance. When all the factors influence your process, and that time you study your process, you will be able to better judge the capability. Sorry, better judge the performance. If the environment is, limited, or if you are conducting the study in a controlled environment according to you, then you can better judge your capability. First of all of you, do you understand how should we conduct the study? If your intention is to understand the capability, you can actually control the environment according to your choice. Take the best machine, take the best operator, take the best material. Let it be everything best of the best. You will see your capability. Are you with me, all of you?
Yes.
Another scenario, you allow all the factors to influence your process. Can shift will influence, yes or no? Day shift quality, the general shift quality, and night shift quality, will there be a difference?
Yes. There will be.
So allow the factor called shift to influence your process. You have to stretch out your data collection. Please understand. If you do not stretch out your data collection, you will certainly be missing to study the effect of a factor called shift. Operators also change. Your operator skill might differ. Suppliers, you deal with the 2-3 suppliers. There could be a difference in the quality of the raw material supplied by different suppliers. There are many ways your process can be influenced positively, negatively. Yes or no? Agree, all of you? If you
Yes.
want to get a closer estimate of the performance indices, you must put everything into consideration while developing a data collection plan. Do you understand? Data collection plan is the key to go closer to the realistic CPCPK and realistic PPPK. If you don't think like this, you just blindly conducted study, you produced some parts, collected some readings, and you are calculating something, that means you are only getting an estimated value of CPCPK and estimated value of PPPPK. They will be far, far away from the values, realistic values. Do you understand what I am telling all of you?
Yes.
Yes.
Do you understand? So it all depends on what you want to calculate. Now tell me, all of you, what are you calculating in your workplace? Are you calculating CPCPK? Are you calculating PPPPK? Are you calculating both? Are you calculating them, different point of time, or calculating both at the same point of time? Tell me, what are you doing? We can discuss.
Sir, bearing bore, seal bore is CPCPK calculated.
Come again, bearing.
Bearing bore value and seal bore value.
Okay. So for bearing bore value and seal bore value, you calculate only CPCPK.
Yes, sir.
Okay. So your customer wanted you to calculate CPCPK and submit the report. Your boss wanted you to calculate CPCPK and submit the report. If that is the requirement, you conduct the CPCPK. So if in those scenarios, if you conduct the study with a very controlled environment means everything is selected by you. Then what will you get? You will get a realistic CPCPK or you will get an estimated CPCPK.
Estimated CPCPK.
Very good. Please know what are you doing and then use it. No worries. Why am I calculating, an estimated CPCK? Because I want to show a very healthier CPCPK to somebody. Yes or no? If that is your intent, proceed with estimated CPCPK. There is one other thing called realistic CPCPK. What is that? Realistic CPCPK. For calculating realistic CPCPK, don't conduct the study in a controlled positive environment. You conduct the study in a live environment. Do you understand what I am telling? Live environment. Process is running. Suddenly, all of a sudden, you should go there and then, collect the data and come back and do the calculation. Now, what are you getting? You are getting
CP
a
and
realistic CPCPK, a realistic CPCPK. Are you with me? Do you understand, all of you? Most of the time, you are expected to calculate an estimated value of CPCPK only. Am I right? Because your boss want to see a healthier CPCPK. Am I correct or not? Your customer want you to submit a CPCPK report and you wanted to show your customer a value higher than 1.67 always. And so, directly, indirectly, you are forced to choose a controlled environment and then your data will give a higher CPK. Am I correct or not?
Yes.
Yes.
See, using the tools is absolutely your capability, your choice. You can use it to for continual improvement purpose. You can also use it, just to project your image, project your, perform. No, your what do you call? Your sometimes, to meet the requirement, you may have to do. So depending on the requirement, you can use it. So, but do it wisely. Point number one. And but when it comes to performance, what is very, very important is again you need to ask yourself: do you want an estimated PPPPK? Do you want a realistic PPPPK? Tell me, all of you, what is your demand most of the time? You want an estimated
realistic.
PPPK or a realistic?
Realistic.
Realistic.
Are you sure? When did you know? Uh, when was your no recent scenario you wanted realistic PPPK? Realistic PPPK, if you want, you have to first of all stretch out your data collection period. You must give yourself the needed time. Agreed, all of you? The data collection itself might run for days together. Just to complete the data collection, you may have to wait for 1 week time, because within 1 week time, all the factors will definitely start influencing your process. First is the shift effect, the operator effect, even raw material, isn't it? Once in 2 days you are procuring raw material. So supplier 1 also supplying, supplier 2 also supplying. Do you think all of them will perform in a very consistent and in a proper agreement manner? No. There are multiple ways, the variation can come and populate. So you have to stretch out the data collection period. And let's say after data collection period is finalized and data collection frequency, then sampling technique, then sample size, all that are decided. Now 1 week of data collection is completed. After the data collection is completed, by scheduling it over a week period of time, now all the data, let us say you got about 300 samples. So how many samples you got? By stretching your data collection over a week, 300 data samples. If you make use of all the samples for the calculation of the standard deviation, then the standard deviation is called overall standard deviation. Do you understand what I'm telling? 1 week time spent. 300 times data is recorded. Now, how many data points you have? 300 data points. Can you type all the 300 data points in a single Excel column and calculate a standard deviation out of it? This is called as overall standard deviation. This is called as overall standard deviation. And now this overall standard deviation, if you apply in the formula, that will give you PP and PPK. Do you understand, all of you, what I explained? So first of all, it depends on what do you want to understand. If your interest is to get an estimate of the CPCPK, estimate of the PPPK, then you can compromise. Compromise in the sense you don't have to collect data for 1 week. You can collect the data in 1 day, no problem. Because your requirement is what? An estimate. An estimated PPPK value. Estimated. If everything is an estimate, you can start violating the requirements. Just to complete your data collection in 1 week, 1 hour also fine. Right? And so data is collected. But right after collection of the data, we can use the data for CPCPK calculation as well as PPPPK calculation. We can use the same data for CPCPK calculation as well as for PPPPK calculation. Now you have to actually look into your data collection plan. See, you are collecting samples. Am I right? You are collecting samples. Now please ask yourself, 300 samples you collected. If all the 300 samples are collected simultaneously, now you can only calculate PPPPK. What am I telling?
Yes.
All 300 samples are collected simultaneously, meaning what?
The same shift.
Same time, you collected all 300. That means production is continuously 300 samples and all 300 you have taken. Now, where is the subgroup? Isn't it? All 300 are one group only. If that is the case, you can
Yes.
only calculate PPPPK, or in other words, PPPPK will equal CPCPK. Do you understand, all of you, what I am telling? Normally for CPCPK, you have to collect samples in subgroup. Subgroup means, let's say you wanted to collect 300 samples. Take samples 10 at a time. 10 at a time, how it can become 300? 30 times you have to take. 10 samples, a time break, 1 hour time break. After 1 hour, another 10 samples. After 1 hour, another 10 samples. After 30 hours, you will have 30 subgroups. Each subgroup will have how many samples?
10 samples.
10 samples.
Okay.
So 30 into 10 is 300. If you take 30 into 10, 300, then CPCPK can also be calculated. PPPPK can also be calculated. Are you following me, all of you?
Yes.
30 samples at a time, 30 times. Now you have 300 data. Now you can calculate CPCPK. You can also calculate PPPPK, right? Both are possible. Another company, they run the machine continuously, produce 300 parts. They measured all 300 parts. Now this another company can only calculate PPPPK. Do you understand? So tell me, for calculation of CPCPK, how should we take the sample? We should take the sample in subgroups.
1 week time.
Subgroups are
Subgroups.
compulsory for CPCPK calculation. If you have taken only a group of sample, no subgroup inside, then only PPPPK is possible. Are you with me, all of you?
Yes.
Yes.
Sir.
If samples are taken in subgroup, CPCPK also possible, PPPPK also possible. Why? All the subgroup can be combined and we can convert that into a group. Not a problem. But group cannot be separated into subgroup, right? So after collecting all 300 in one go and saying that, no, sir, I collected 10 at a time, that is not logical. So please understand. So now I will show you an example. Then you will definitely be able to better understand, right? So I'm sharing my screen. I'm going to open the same Excel file which we normally use. So we'll see that calculations and all the steps I have done manually also. And we can use Minitab also, sigma level calculator. Give the password. Yes, password is given. Now I am going to a sheet. Coating thickness. Are you seeing coating thickness, all of you?
Yes, sir.
Now let us take a deeper look. See here, roll number 1. How many samples are taken from roll number 1?
3.
3 samples. Because the raw material is coming in the form of a roll. The roll is completely consumed. Let's assume 1,000 parts are produced. But we don't measure all 1,000. We measured only 3 out of the 1,000. The first roll is finished. After some time gap, the second roll is loaded. 3 more samples are selected. Third roll is loaded. 3 more samples. In this manner, totally 25 rolls are consumed. Now please tell me, sample is collected in subgroup or sample is collected as a single group? What is your answer?
Subgroups.
Subgroup.
Good. Sample is collected in subgroup. So CPCPK can be calculated. PPPPK can also be calculated. But there will be a difference in the formula. Where exactly is the difference? Standard deviation calculation, there is a difference. For CPCPK calculation, you have to use R bar by D2. For PPPPK calculation, you have to use a overall standard deviation formula. Under root of summation of x minus x bar the whole square divided by n minus 1. For overall standard deviation, n will be equal to, see here, how many samples? See here, how many samples?
77 samples.
75 samples overall. So for PPPPK, n is 75. But for
75.
CPCPK, what is your n?
3.
3. Because every subgroup you only have taken 3 samples. For
Yes, sir.
CPCPK, sample size is equal to subgroup size. For PPPPK, n is equal to total number of samples. Are you, all of you? If you have all this clarity and your calculations can be more realistic, and you will get to understand what you want. Otherwise, it will be a complete chaos. All right. So now let us understand how to calculate CPCPK with the help of this data. Then I will also tell you how to calculate PPPPK. Are you ready? Shall we do it?
Yes.
Yes, sir. Yes.
Okay. See here, the sample is collected. Now the data collection plan is, clearly explained to you.
Sir, voice is not coming.
Yeah, I'm coming. 1 minute. Priya? No. No. You check who's this. Yeah. Okay. So there is data here. So 3 samples from roll number 1, 3 samples from roll number 2. See here, the first 3 together is called a subgroup. For the subgroup, you calculate subgroup average. Is it very simple, right? All of you? Subgroup average is what? X1 bar. Am I right? Come on, please answer me.
Yes,
Subgroup
yes, sir.
average is X1 bar. Do you understand, all of you, what is X1 bar? Average of the 3, right?
Yes.
Okay. Now this is subgroup range. The symbol is R1. How to calculate R1? The maximum within the 3 minus the minimum within the 3. What is maximum? I think 50.4 is the maximum. What is minimum? 50.14 is the minimum. So the difference between maximum and minus minimum is this. In this manner, you have to calculate 25 averages, X1 bar, X2 bar up to X25 bar, then R1, R2 up to R25. Are you with me, all of you?
Yes, sir.
Understood? Okay. Now, once you have R1, R2 up to R25, you see here R25. All the ranges are available. There are 25 ranges. Yes. Now what I want is, I want you to calculate R bar. You know what is R bar? average of the ranges. Can you calculate average of 25 ranges? Tell me what is the formula? R1, R2.
R1 plus R2 plus 25 divided by 25.
Very good. Everything divided by 25, isn't it? Of course, we have to write the formula and everything correctly. So this is the method I used. And now my R bar is available. Can you see here, all of you? R bar is available. How much it is? 0.700816. Now all that we need to do is divide this R bar by a constant known as D2. How to get the D2? We can go to Google and D2 value for sample size or subgroup size equal to 3. Am I right? Table is readily available. What is this?
The table is already available, sir.
Yeah, that is available. We can just know, even Google also can tell. See here, Google also gave the same answer, correct answer, 1.693. Let's go to 1.693. So all I need to do is this value of R bar divided by 1.693. Now how much it is coming? 0.4139. All of you, are you seeing 0.4139? Now I have taught you how to calculate within standard deviation manually, 0.43. Now there is one other thing we must understand: overall standard deviation. What is overall standard deviation? All the samples you must convert into a single group. Let me show you. Have I converted everything into a single group now? Are you seeing 75 samples?
Yes.
Now for all the 75 sample, you calculate the standard deviation. Standard deviation simultaneously. In Excel, there is a formula stdv.s from this point to first point. Close this, enter. Now, what is the standard deviation? 0.8384. Now, that overall standard deviation is made available here. Within standard deviation is made available here. If you make use of 0.4139 in your formula, it will deliver CP/CPK. If you use 0.8384 in your formula, it will deliver PP/PPK. Those delivered values are available here. Can you see here, all of you? CP is how much? 2.41. CPK is how much? 2.32. But PP is how much? 1.19. PPK is how much?
1.14.
1.14. What do you understand? Your PP, PPK are smaller compared to CP and CPK. What do you understand? Tell me, what do you understand?
Capability is there, but performance is not good.
Capability is not there. That means for short-term application, the process is acceptable.
Correct.
Whatever is the capability,
Under
short-term
control.
application, it is acceptable. But for long-term application, you have to think over whether to continue with the process or you want to improve. I'll tell you what exactly is this. By feeding the data in Minitab, we'll take. Now we have calculated. We have done the calculation manually. Now I'm going to use Minitab, and Minitab will quickly do all of these things. And all of you, please note the topic you just now learned is a very, very important topic. And though it looks, more or less similar, CP, CPK. First of all, CP and CPK itself, there was a lot of confusion. I mean, there are a lot of similarity, but they are different. Similarly, PP, PPK and CP, CPK also, there are a lot of similarity, but they are different. But we are able to thoroughly understand, right? See now here, whatever data I copied from the Excel, I have pasted here. Now what I'm going to do, I'm going to do a capability analysis with the help of Minitab and see whether we get a similar result. Go to Stat. Go to Quality Tools. Go to Capability 6 Pack. Go to Normal. What is the root? Stat, Quality Tools, capability 6-pack, and then normal. You have to click. Now this window is coming. Data is available in single column. Yes, the column is C1, which is coating thickness. And subgroup size. What is the subgroup size in our data collection?
3.
3. You can type 3. Now lower spec and upper spec. This is coating thickness. The target is 50 microns. Lower spec is 47 micron, plus or minus 3. Upper spec is 53 microns. Now I am giving OK. Now Minitab will manage the show for me and it will throw the graphs. Are you seeing, all of you, the graph?
Yes.
Are you seeing the graph? Now, all I want you to understand is, first look at the CP value. 2.46, is it similar to the value we got? We also got 2.46. Do you remember?
Yes.
Yes. CPK 2.37. But PP 1.19, 1.15. What is the significance? If you look at the ppm for short term, ppm is how much? Parts per million?
0.
0, no rejection. In short term, rejections are no rare, not possible. But in long term, imagine how much ppm is expected.
393.
But what is short term? What is long term? You have to know, understand from your business, conditions. It depends on, how many parts, what quantity you manufacture, and all those things. How frequently you manufacture, and if you are if if the order you are processing is only 300 numbers or only 3,000 numbers, then you don't have to depend on PPPPK. Not required. But if you are supplying to your customer, continuously every day 10,000 parts you are supplying to your customer, then you definitely require PPPPK also. So the ppm can increase from 0 to 394 in the long term. Do you understand, all of you? And see here, always when you refer the capability metrics, it's very important to keep an eye on the control chart. Look at your control chart. Can you see your R bar value? This is what we calculated also. This R bar is here. The X double bar is here. And look at the red color points.
Hey.
If there are so many red color points indicate what? Special causes. Red color point indicate what? Special causes. So special causes, if there are too many special causes, then the credibility of your CPCPK, the PPPPK calculated, will be lost. Do you agree with me, all of you? If there are too many red color points in the control chart, then CPCPK, PPPPK, what we calculated, may not be realistic. They might be giving you a misleading, values. Do you agree with me, all of you?
Okay.
Yes or no? So what, as a company, what are you supposed to do to avoid this, misleading communications? For each and every red color point, you must have action taken report. Because this is a special cause, some root cause analysis has to be carried out and action taken report must be maintained. Do you agree, all of you? If such a habit is there, then the CPCPK can be realistic. Otherwise, it will be misleading. So make sure your X bar chart is under control. Make sure your R chart is under control. And then make sure your data is normal. This is a normality plot. Look at the p-value. P-value of more than 5% is required to assume data is normal. If p-value goes below 0.05, then normality cannot be assumed. So normality is disturbed. The data is considered to be abnormal. Then again, the values can be misleading. Now data is normal, but only problem is here with this capability analysis, I am seeing only the X bar chart, so many red color points, which is some kind of which is actually demanding proper action taken report. Otherwise, the report is good only because CPCPK is healthier. And this report definitely, if my requirement is CPCPK, I'm okay with this values itself. But if my requirement is also PPPPK, then I may have to probably improve the process and lift the capability to further higher level. Then only my overall PP and PPK will improve. Do you understand, all of you, all whatever I have explained here? Or any questions to me? Come on, please confirm. Have you understood or are there any challenges? Come on, all of you who can come on screen one more time. I want to see you after learning CPCPK and PPPPK. Do you know, appear the same way like before learning CPCPK and PPPK, or have you changed?
Sir, we have understood CP and CPK, sir, but PP and PPK, there is a separate formula for upper and lower, sir.
Formula is same, but the standard deviation will be different. For
The
PPPPK,
formula remains same.
see, PPK is will be equal to PP upper or PP lower. And PP upper, PP lower formula will be similar to CP upper, CP lower only. But wherever standard deviation is coming, what is the formula we should use for standard deviation, for calculating PP, PPK? Under root of summation of x minus x bar,
X bar the whole
minus
square.
1.
Yes, sir.
So the secret is the formula of the standard deviation. PPPPK, the standard deviation used must be overall standard deviation. CPCPK, the standard deviation used must be within standard deviation. Within means R bar by D2, overall means under root of summation of x minus x bar the whole square by n minus 1. Okay? So now
sir.
tell me, do you now understand when to go for CPCPK and when to go for PPPPK?
When we need within standard deviation, we have to go for process capability. When we have to find out overall standard deviation, we have to go for performance.
Okay, so he's very technically speaking. Somebody should speak normal.
Sir, if you want to
Based
know
on
the
the
long-term and
sample
short-term
group, we
performance, I
calculate.
think both are required.
Very good. If you want to understand your capability for short-term purpose, what is short-term purpose? You have to define it first, isn't it? Everybody will have a definition about short-term and long-term, yes or no?
Yeah,
Yes, sir. Yes, sir.
Your examination, do you know when is your exam? Your exam, the week after next week, isn't it?
Yes, yes, yes.
Whatever we prepare, do you remember? Whatever we
exactly.
prepare, remembering for 2 weeks is not a difficult job for you. But when is your interview, promotion interview? That is, maybe March, April, or we don't know. So that is long term for you, isn't it? Because you definitely have a doubt whether I will remember everything on the day of the interview. No.
Yeah.
So you have to tighten
Influence
your goals
factors.
now to a higher torque if your expectation is long term. Do you get my point? Do you think we can't prepare all of you for long term performance? Can we prepare all of you for long term performance? Am I right?
Yes.
We can call all of you, for a 1 week live workshop in Chennai, and then every day there will be some exercise, and afterwards 2 to let's say 12 weeks of project work, and again after completing 12 weeks of project work, all of you come to Chennai and then meet us. If we do all these exercise, your capability will become what? Long-term capability, yes or no?
Yes, sir.
Yes.
It depends on how you plan your data collection. And also your requirement also matters a lot. If you have come here just to pass the exam and then get your certificate, then your requirement is just CPCPK. If you have come here for what do you call a transformative growth in your career, you wanted to transform your leadership capability, then your goal is different. All right. So accordingly, we have to use. So that means your aim is long term. So you need to correctly judge whether your requirement is short term or long term. Okay. Imagine you are appointed as an auditor to evaluate one of your supplier because your company want to work with the supplier for next 5 years. Now tell me, what is your requirement? Long term, short term capability or long term performance?
Long-term
Performance.
Now what will you ask for when you go for audit? Will you ask for just CPCPK or will you also ask for PPPPK?
PP and
CPPK.
PP.
Yeah, you should ask for both. If you notice a difference between PPPPK and CPCPK, what would you like to advise to your supplier?
To change the process.
You will certainly advise your supplier to improve the process, isn't it? And then probably you may go for a re-audit after 2 months or after 3 months or after 2 weeks or 3 weeks. That way you wanted to ensure your supplier will have a higher PPPPK as well as higher CPCPK. Please note, the moment you understand your requirement is PP, long term, you must demand higher PPPPK. But imagine it is a short, a kind of contract job where the contract is only for a limited numbers. Let's say the customer has placed an order for, let's say, only 2000 parts. You just have to make 2000 parts and then you want to supply. It's a one-time order. Now tell me, what is important to you now? Short-term capability or long-term performance?
Short-term.
You're judging correctly because it's only for you just have to produce 2000 parts without any defects. Achieving, the CPCPK itself is enough. Are you with me, all of you?
Yeah.
So this is how you need to judge between. And but if you want to be on a safer side, yes, always demand for a higher PPPPK and also demand for a PPPPK closer to CPCPK, and also always understand the data collection plan is very crucial. Data collection plan is very crucial. If the data collection plan is developed in a proper way, then your estimated CPCPK, estimated PPPPK can slowly move towards realistic values. When do you want to see your realistic values? When do you want to see your estimated values? That depends on your requirement. I think you all have the answers for it, isn't it? If you want to submit a very healthier value to your customer, you are okay with the estimated value. Am I right? If you want to do a self-assessment for a continual improvement practice, then you may want an accurate, realistic CPCPK and PPPPK values. Plan accordingly. It all depends on your data collection point. So that's it from
Sir,
me
one
on
question is here.
process capability and the process performance indices. Yeah, any question? Please, most welcome.
Uh, yes, sir. Actually, if we are seeing the suppose long-term vendor for 5 years, as you have stated here, and we are seeing the capability of vendor is there. This CPCPK is good, but PPPK is not good. Then even we can advise, yes, you can improve because you have the capability. Your performance is particular time is low. Then we can go ahead, I think. Is it?
Yes. If the CPCPK is good and PPPPK is not really acceptable, in such a case, yes. That means if the process is allowed to run for a longer time, it deteriorates. So some frequent monitoring and frequent calibration of the process is required. That's why every single shift we again ensure the settings are okay and all those things. Because maintaining the capability for 8-hour shift is possible. But once the shift is over and changeover is happening, all some kind of what do you call, some calibration is done, and some all the settings are one more time checked, and then another 8 hours the process will run with the required needed capability. So what I'm trying to say is, if PPPPK is weaker compared to CPCPK, then process might require frequent monitoring.
Yes. Agreed, sir.
If
Thank you.
PPPPK also longer, that means your process is designed to perform for a longer term, and so minimal monitoring will also do. But again, but if you further ask me, sir, what is minimal and what is frequent, that all those things you have to judge correctly. It depends on the specific process. Good question. But if
Sir,
CPCPK
then
itself is bad, then you have to reject your supplier. But if PPPPK is bad, but CPCPK is good, you can give him a chance. Yeah. Oh, I think somebody
CP
is
and
asking another
CPK
question.
value is 1.33, 1.672. The PP and PPK value also remains same, sir, for
Oh,
comparing.
if CPCPK is 1 point, you said CP 1.33, CPK 1.6, right?
No, sir. For CP and CPK, the number is 1.33, 1.672. For PP and PPK also remains the same.
What is 1.33? What is 1.67?
That is the number, sir. That number denotes within the process. We are the specification
See,
limit
you tell
within the
me, what is the value
specification.
of CP? Tell me CP value how much? 1.33.
33.
CPK?
No, sir. My doubt is simple, sir. CP and CPK has number 1.3, 1.672 like that. Like
See,
that
wait.
only PP and PPK also is remains the same. That I am asking, sir.
See, you are telling all values 1.33, 1.6. You choose one value. Let us say your CP is 1.67, CPK also 1.67. Okay.
Okay, sir.
That means, your short term, definitely your process is capable.
Okay.
But for long term, you need to look at PPPPK. And if
PPK and the
PPPPK,
value also remains the same or it will differ, sir.
no, it can differ. It can differ. See, CP and CPK can differ.
Okay.
CP can differ from PP. CPK can differ from PPK. But your job is to make all of them look same. That is your job.
All should be synchronized with this. Four should be synchronized.
All of them should become 1.67 at least. Like at the end of the training program, all of you should become a black belt. If somebody is brown, somebody is blue, then there is a problem. Correct? Your job, your role in your company is to run a process which is stable, capable in short term as well as long term. That is your job. You do whatever that is required. If you understand long term capability is a problem, then you do no frequent calibration. Yes or no?
Yes, sir.
Like all measuring instrument, you are frequently calibrating. Why? You know over time it will deteriorate. Same thing is
Yes, sir.
applicable to your process, your machines as well. Some kind of calibration. Calibration is no completely no, the machine should undergo some kind of overhauling. They call it machine overhaul, isn't it? Your two-wheeler and
Yes,
car and
sir.
other things, you do frequent service, isn't it? You know why?
Yes, sir.
Because you
Sir,
want the vehicle
to
to remain in the
increase
same
shelf life,
condition.
sir.
long term.
To increase, yes, sir. To increase shelf life.
But certain vehicles nowadays they say no maintenance required. You can just start and then drive. No maintenance. That means those cars are designed with higher performance, long-term performance. So that means they are very robust in design. So lesser maintenance required. In those cases, PPPPK will be equal to CPCPK. Good question. I strongly suggest all of you to read some literature also. You study some, the same chapter from good books. And we normally email some 3 books to all of you. After the course is completed, you will receive a mail. In that, there is a handbook for Six Sigma. That will have about 800 pages. And the author is Thomas Feistek. And you can certainly find a chapter on CPCPK, a chapter on PPPPK. I want all of you to read it at least once. Will you do that, all of you?
Yeah. So who is writer?
Yes, sir. Yes, sir.
Thomas Feistek. The author name is Thomas Feistek. The book name is Six Sigma Handbook. There will be chapter called Process Capability. And in that you will see CPCPK as well as PPPPK. Now, after attending, this session and having a lot of clarity, if you read the book, certainly you will be in a position to understand and try to read, try to add more understanding to your, the knowledge base on CPCPK, PPPK. That will certainly help you to
Sir,
differentiate from.
sir, 2 minute little bit confusion हो गया. For short term and long term PPK और PPK वो थोड़ा सा brief कर दीजिए सर. Just brief the what is for short term, what is for long term. Little bit confused हो गया.
Short term is CPCPK, long term is PPPK. For short term purpose, look at the CPCPK. Be happy with the CPCPK. But for long term purpose, in addition to CPCPK, you should expect a healthier value of PPPK. Okay. Long term is PPPK, short term is CPCPK. Okay, and try to know use it in some kind of real term application. Then you will realize when to go for the CPCPK and when to go for PPPK and all. Okay. All right. So I think we can move on to next topic. And prior to that, let us take a short break. Now it is 4:58. 15 minutes break from here. You can refresh and come back. Okay. You have another interesting topic. What is that? Another topic?
AAA.
DOE.
Okay. Not DOE now. And I think there are two more. Attribute agreement analysis. Another one is proportion test and chi-square test. Proportion test and chi-square test. So if you look at the topic or the terminology used, all these topics are related to a kind of data called as attribute data. Kind of data called as attribute data. And attribute data means it is qualitative in nature, not numerical. It is qualitative. Like, you are classifying your parts into good and bad, or okay, not okay, or like pass and fail. In such a case, definitely all these tools comes into picture. Right? It's not a measurable data. It is an attribute data. Even attribute agreement analysis is a kind of MSA. Attribute agreement analysis kind of MSA where the outcome of your measurement is in attribute format. Imagine you and me both are involved in classifying the parts. We are inspecting the parts, and we can pass or we can also fail the part. Fail means it is defective. Pass means it is okay. So if we both are doing the job, we both have to do it, in a consistent way, in an accurate way, which is called attribute agreement analysis. Similarly, with the same data, if you consider a hypothesis testing scenario, then the test will be called proportion test and chi-square test. So let me get the slides and then we'll talk about it. Yes. Just I'll show one slide for AAA, and then we can move on to the. Please confirm, are you seeing my screen?
Yes, sir.
Yes.
Yes, sir.
Yeah. So I want you to only look at the table here. Yes, I'll enlarge that. Yes. Can you see attribute agreement analysis, all of you?
Yes.
Yes.
Magnify the slide. This area I want to show you. Yes, attribute agreement. And now look at the first column. Is that recording going on? Yes, it's going on. Right. If you look at the first column, it is sample number. How many samples are here?
14.
14.
There are 14
14.
14
samples.
sample.
The standard is also available. The standard available in the sense the part nature is available. That means all the pass means good parts, fail or bad parts. So you see 3, 5, 7 parts are failed part, 7 parts are good part. Now we involve 3 appraisers, appraiser 1 or operator 1, operator 2, operator 3. We want each operator to check each part 2 times. We want each operator to check each part 2 times. And they have to align with the standard. If they align with the standard, it's called accuracy. Do you understand, all of you? If they align with the standard, it's called accuracy. And since they are made to measure each part 2 times, if they give the same reading, it is called consistency. Particularly, it is called operators repeatability. Are you with me, all of you?
Yes, sir.
If
Yes,
you
sir.
measure a part and classify as pass, and both times you are classifying as pass, you are repeatable. But sometimes repeatability can also be a problem. You see, operator 2, can you see first, operator 2, first time he says pass. Second time he says fail. That means
Fail.
he is not repeatable. So operator repeatability is important to achieve accuracy. And moreover, operator 2 also involved, operator 3 also involved. Look at the third sample. Part is fail. Part is fail. Operator 1 classified it correctly, accurately, is repeatable. But operator 2, is he repeatable?
Not repeatable.
No.
Is not
Not repeatable.
repeatable. As a result, he is not accurate. As a result, his
Not
accuracy is also compromised. And moreover, operator 1, operator 2, operator 3, there are 3 operators involved. Just because operator 2 doesn't fall in agreement with 1 and 3, the team reproducibility is also lost. Can you see that, all of you? Team reproducibility. No. Why no? Because he doesn't align with the other
Standard
operators.
data.
If there are a team of 3 or 4, it's very important that we align with the team while making decision. So there is a term called operator repeatability. There is another term called team reproducibility. When it comes to team, we call it reproducibility. If team reproducibility is lost, automatically team accuracy will be lost. If operator repeatability is lost, the operator accuracy will also be lost. Hope all of you understand all my statements. Correct?
Yes.
Okay. Now let's evaluate this measurement system. This measurement system is consisting of 3 operators, 14 samples. Of course, the instrument instructions are there. First part, pass, 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 fail, fail. Now operator 1, repeatable, 2 repeatable, 3 repeatable. But my question to you is, are they reproducible?
No.
No.
Reason? What is the reason why it is not reproducible?
They are not aligning with the data.
Because 3 is not aligning with 1 and 2. There is a problem with your 3 and team reproducibility is lost. As a result, team accuracy also lost. No. Coming to 2. Are they reproducible here with the part number 2? No.
No.
Again, no. Are they reproducible with part number 3?
No.
No. And so team accuracy also no. But for part number 4,
Yes.
everybody says it's fail, 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 fail. there is reproducibility, there is also accuracy because standard is also failed. But fifth one, there is a problem here, no reproducibility, no accuracy. Sixth one, all pass, there is reproducibility, there is accuracy. Seventh one, there is pass, but everybody says fail.
Reproducibility,
There is
no.
reproducibility, but there is no accuracy. Do you understand? And part
Yes.
number 9, right? 9, pass, and everybody says pass. So there is reproducibility, there is also accuracy. Part number 10, fail, but there is pass and fail coming. There is no reproducibility, there is no accuracy. Part number 11, there is reproducibility, there is accuracy. 12, there is reproducibility, there is accuracy. 13, there is reproducibility, there is accuracy. 14, because of this element, there is no reproducibility, there is no accuracy. Now we just have to come out with some numerical values to conclude. What is required is a team accuracy of 90% is required. AAG guideline says a bias must be limited to 10%. That means team accuracy should be 90%.
90%.
Out of 14 samples, how many times the team has come up with the accurate finding? How many S here? 1, 2, 3,
3,
4,
4,
5,
5,
6.
6.
5, 6. 6 out of 14.
6
How
by
much is
14.
6 out of 14?
43%.
42.86%. And which is not sufficient. What is the requirement? Team accuracy must be 90%.
90%.
If you want team accuracy, there are two other elements important. Team reproducibility is important. First thing is team reproducibility. Overall, actually, contributing to poor reproducibility, I think operator 2 here, am I right? Operator 2 here. Again, operator 2 here.
Operator 2, 14
Again,
sample.
I think operator 2, if we could improve.
Sir,
And
I
again
have
here
small
also.
doubt, sir.
Operator 3 also, sir.
Operator
Sir,
3
I
also
have small
problem.
doubt,
Yes.
sir.
Yeah, please.
Sir, if we can't depend on team reproducibility, sir, because everyone can make a mistake and we can't get the number, sir. We have to see on
Okay.
team accuracy, sir.
No,
If
see,
reproducibility,
team, please note. Every time a no is written here, you are seeing a no here.
yes, sir.
That means
No,
without
sir,
team reproducibility, you cannot have team accuracy. So team
no, sir,
reproducibility is
you are,
important.
okay, sir.
You have to achieve. See, it's a matter of consistency. We all have to, align to one single procedure. Then reproducibility will come. Okay. So team accuracy is 42%. Now let us calculate team reproducibility. How many S here? 1, 2, 3, 4, 5, 6, 7,
7,
8.
8.
8 upon 14 is 57.14%. So we need to improve the team reproducibility. So thereby, the team accuracy can also improve. And another thing we need to look at is operator repeatability. Operator 1, every time the trial 1 and trial 2, if both are matching, the operator is considered to be repeatable. You see, all 14 times he repeated the same result, same outcome. Can you see here?
Operator 1 and 3.
So his repeatability is
100%.
100%.
Yes.
100%.
But is he also accurate? That depends on the standard part. Pass,
No.
so is accurate. First time it is okay. Second time it is okay. Third okay. Fourth okay. Fifth okay. Sixth okay. But seventh there is a problem. Can you see that?
Yeah.
One out. Eighth okay. Ninth there is a
Ninth
problem.
problem. 10th
Tenth
problem.
also problem. 11th is okay. 12th is okay. 13th okay. 14th okay. That means he 3 times he is not accurate. That means how many times he is accurate then out of 14?
11 by
11
14.
times.
So 11 by
times.
14 is how much?
83.
No, 11 by 14 is it 83? Are you sure?
79, sir.
78.5.
79.
Yeah, then this is the
79.
value. Correct. Then this is correct. But operator 2, 64. Operator 3, 71. And see here, all the operator lag in terms of accuracy. You need to train them. And who is least accurate? Operator 2.
2.
Then operator 3. Of course, operator 1 also needs to be trained. And similarly, reproducibility is contributed by mostly the operator 2 and 3. And somehow, if you could standardize the measuring procedure and all that, the reproducibility will improve, repeatability will improve, and finally, the accuracy will also improve. So the attribute agreement analysis demands a team accuracy of 90%. Do you understand, all of you? Will you be able to do
Yes.
this? Will you be, yeah? Here, the
Yes.
requirement is you need standard parts. Standard parts are required if you want to calculate team accuracy, right? So this is one thing. So any questions on this?
No.
Mm.
Ideally, it should be 90% both reproducibility
Yeah,
and
correct. Yes, you're right. So accuracy has to be 90%, which is possible only if the reproducibility is 90%. Correct. They're interrelated. We need to improve, in all aspects.
क्लास चलेगा उसका हाँ
Sir, is it standard percentage of 90% or it varies about from the program or the projects we work?
No, ma'am. The team accuracy, like gauge R&R rule, similar to gauge R&R rule, the accuracy required is 90%, but 70 to 90% is somewhat okay, like conditionally acceptable. But below 70% is unacceptable. And again, the accuracy depends on the agreement within the team. So the repeatability and reproducibility needs to be looked at. And so the operator repeatability and team reproducibility, if there are issues, so please improve. And then see where are we going wrong. Some kind of investigation can let us understand why our team is biased. So minimize the bias, automatically the accuracy will improve. So, but if the problem continues, then probably you have to improvise your measurement system, and maybe you can also switch to measurable data, right? If the good bad study, if your team is not able to do properly, then you can give them a proper measuring instrument. So measuring instrument can come out with some measurable values. So there will be a strict guideline available. No, whether it is below or above the critical value. So that is why we always prefer continuous data. But discrete data means yes, some the skill of the operator is important and agreement within the team is important. Okay. So
Got
now,
it.
yeah,
Thank
I will proceed with the proportion test and chi-square test. So for that, I will equip all of you with conducting the, what do you call, the proportion test and chi-square test using Minitab. Using Minitab. So what I do, I'll open the Minitab. Yeah, Minitab is already open. All right. So I have opened the session window. So what are we going to do? We are going to do proportion test and chi-square test. Please note, when you want to perform this test, your data type must be attribute. Attribute in the sense, you very well know, the outcome is like Yes, no. Yes, no. Good, bad, pass, fail, etc. So these kind of things. Now, when we have good, bad, yes, no, and these kind of things, what we do, we count and find out the ratio. We count and find out the ratio. Imagine there is a digital marketing campaign. Digital marketing campaign. Your company is running, and your company's understanding is they get 6.5%, 6.5% conversions. What is 6.5% conversions? Out of 1,000 inquiries generated, 65 people make a purchase. Am I right? Do you understand, all of you? What is the conversion here? Is it 6.5%?
Yes, sir. 6.5.
Yes.
This is your company's understanding. So the null hypothesis. Null hypothesis means H naught. Conversion rate is 6.5%, or you can call it 0.065. Now your digital marketing team, they have developed a new campaign. And they claim that they have achieved 8.5% conversion. Now, do you see a difference in the conversion? Do you see a difference in the conversion? Suddenly, they developed a new campaign. The new campaign is giving what? 8.5%. Now, my doubt is this difference, is random or statistically significant? This is the question. If the difference in the conversion rate is statistically significant, you can declare the improvement is because of the new campaign. The credit can be given to the new campaign. Are you with me, all of you?
Yes, sir.
Yes, sir.
We are comparing percentage conversion of old campaign and percentage conversion of new campaign. There are two groups. The data comes from two sources. This is called two proportion test. Percentage conversion is a proportion. This is not an average. If we are dealing with average, if we are dealing with the measurable data, then we have two sample t-test already studied. Now, this is not coming from measurable data. This is attribute data. So the test required is, what is the test required? Two proportion test. Are you with me, all of you? Do you understand when to go for two proportion test? Please confirm.
No, sir. Once again, sir.
The null hypothesis is proportion 1 is equal to proportion 2. The alternate hypothesis is proportion 1 is not equal to proportion 2. Or you can always say P1 more than P2 or P2, P1 less than P2. That is also okay. But when you have more than here, then you must bring less than or equal to here. Always in null, there must be equality symbol. In alternate, inequality symbol. Okay, so this is called a two proportion test. Let's see how the test, the click works with the Minitab. Then we will be able to do it for our real cases. So you have to click stat. You have to go to basic stat. Then you have to come here to two proportion. Can one of you read out the description that is coming up for two proportion test?
Determine whether the sample proportions
of an event for two groups differ significantly.
Determine whether the sample proportion of an event for two group. What is the event? Conversion is the event. For first group, your company old campaign, the conversion is 6.5%, 65 out of 1000. But for our group, our campaign, the conversion is 8.5%.
8.3.
Can this difference should be considered, same and improvement is random, or can I consider the difference as significant? And can I give the improvement, the credit to the new campaign, right? So let's see, let's do that. So let's click two proportion test. Oh, I think I clicked wrongly. Stat, basic stat. Let me go to two proportion. See here, data. Do we have data here? No, we do not have data. I straight away gave you summary. So please choose summary. Are you with me, all of you? You can also
Yes, sir.
say no, good, accepted, no, converted, not converted kind of data, or you can go for the summary. When you go for the summary, the sample one is the old campaign. In old campaign, let us assume the trials are 1,000. Out of 1,000 people, how many people purchased? 65.
65.
But in the second campaign, for the same 1,000 inquiries,
85.
85 people made a
80.
purchase. So go to option. Now the confidence level should be 95%, which means alpha is 5%. And then hypothesized difference, the difference in the proportion, you see here, sample 1 proportion is 6.5%, sample 2 proportion is 8.5.
2%
If you say the
difference.
difference exists, then it is alternate.
2%.
But what we want is a null. So you have to say 0. So hypothesized difference is 0. But alternate not equal to 0.
Why 0,
And
sir? There is a variation of 2%.
see, null hypothesis means you should always say there is no difference. I think you all have studied, the guidelines for writing the null hypothesis. Even though, see, number wise, there is a difference. If you consider the difference is due to random, even though there is a difference, we'll still consider both campaign as equal only. So saying that the campaigns are equal is null. Now we have to check whether the null must be rejected or not. When will we reject this null? If p value goes below 5%.
Less than 5.
Yeah, if your expectation is the campaign 2 is all significantly producing better result. In such a case, null must get rejected. If null must get rejected, p value must go below 5%. And you can follow any method that you are okay with. No problem with this method. Estimate the proportion separately. Some noise, Ajay. Some noise is coming from Ajay K. You have to mute. Okay. So I choose all this option. I give OK. And I give one more OK. Now Minitab has done the test for me. Now all that I want to understand is I want to understand the p value. How much is the p value? Is it visible to you?
0.16.
P value is 0.1. 0.110 means p value is more than 0.05. So
There is a difference.
Fail to reject.
fail to reject the null hypothesis.
Null
That
hypothesis.
means even though
Alter.
there is an improvement in the conversion, it cannot be considered as significant improvement. So we are still concluding that we are failed to reject the null, right? No, failed to reject the null means what?
There is no difference.
Accept the null. Accept the null means both campaigns are
difference.
performing equally only. Even though the number shows a difference, the difference is not statistically significant. It can be the chance of the difference misleading you is very high. So you should not believe the data. Are you with me, all of you? Now, let me redo the test. Basic stat. Two proportion test. Now, instead of 1,000, I'm saying, let's say 2,000. Let me say 170. Let's see what happens. And now, are you seeing a difference in the p-value, all of you? As the sample size
Sir,
increases, my confidence
Still high
increases.
now,
Can
sir.
you notice? Yes.
Yes,
As the sample size increases, my confidence goes high. And in fact, there are two methods followed: Fisher exact test, and there is another thing is test for difference. The test for difference gives a p-value of less than 0.05. Can you notice?
Yes, sir.
yes, sir.
If you are able to notice a p-value less than 0.05, that's the time you can reject the null and you can announce that campaign 2 is significantly better than campaign 1. Anybody installed Minitab in your laptop? Will you be able to share the screen and do it live right now, like how I did it? Because here, more than knowing the formula, you should be able to actually understand when to go for a two proportion test and then how to use softwares like Minitab or any other software. But ultimately, you should also be able to read the analysis and interpret correctly. Anybody would like to do it? Yes or no? No one is ready.
I can do it, sir.
Yeah, please do it. I mean, Shagit, share the screen.
Not so familiar with Zoom. Let me try. How do
Right.
I?
The bottom there is a share screen. Share your screen.
Yeah, okay. Are you able to see my screen?
Yes.
So now
So that
Naveen
summer,
engage all of you. Yes, you can talk to participants. Correct directly.
right? So that summary, where should we enter that actually? Like,
No.
it's
See,
a new sheet we have to
I was
open.
just typing under the session window, but it's only optional. You no need to type anywhere. You straight away you go to the stat and start doing. If you want to enter under the graph only, under the graph, but I think advanced version, it may not allow you to type. Yeah, go to two proportion. Very.
To proportion. And
There won't be any data.
And you don't have data, rather you have a summary. So change it first.
Summary.
summarized data. Here, number of events,
65.
we would say
65 by 1000.
mm,
85
uh,
85 170.
Sir, one question
Sir,
on
I
this,
have
right,
done.
is
Yeah, please.
so there is a 6.5 and 8.5, which is like of the same trial size, right? So there is a 2% difference. So that 2% will be considered as not significant even if the value in terms is also higher. Say for example, if it is like a 100 million project, the 2% will be like 2 million. So still will
See,
that be
always there
considered
is a
as
common sense decision. There is, statistical decision. Two decisions are possible. And your common sense says, oh, there is a difference, isn't it?
right?
And there are times where, it is good to proceed with common sense. There are times where, it is good to proceed with statistics. You need to decide which is good for you now. If everyone around
So,
you is data driven, they expect you to be data driven, they want you to be, have some scientific evidence which everyone follows, then you have to wait for the statistical significance to declare campaign 2 is better than campaign 1. Okay. But if you want to announce in a hurry because you have sent 1,000 emails and 85 people out of the 1,000 emails, they made a purchase. It doesn't mean you are, campaign B is better than campaign A. I do not know what will happen to the next set of 1,000 emails. Are you getting my point?
Right. Yeah. Yeah.
If I send another set of 1,000 email, will I again get 85 sales? That's why, when I changed 85 to 170 and 1,000 to 2,000, the p value was changing, isn't it? Because if this is going to occur again and again and again, then the confidence level will go up. As the confidence level goes up, the alpha risk will go down. So you can change and even study. So 85 out of 1,000 right now, the p value is not really supporting, isn't it?
Right.
So go to options and do the procedure. See, this is a standard practice. We call it statistical approach. You can use the statistical approach used by all statisticians and scientists, and you can also remain scientific in your decision. Or at times, it is good to avoid all these tools and simply go with your common sense, engineering logic, and all that. If that is found to be good, only in those cases you can ignore statistics and proceed. So far, before learning statistics, you all might have done it, only based on what do you call the common sense and engineering logic only. Yes or no?
Yeah, that's true.
But now that you learned statistics hereafter, see whether statistics and common sense, your engineering logic, all of them align. If all of them align, then your chance of your decision going wrong is very, very minimal. So wherever stat can be used, please use stat. Okay, now you know why are you typing 95, why are you typing 0? All those things you are aware of. Am I correct?
Yes, sir.
Yes.
Because null hypothesis is saying that, both are equal. So 0
Okay.
is on the difference.
Sir, I
Okay,
have
you can
some
give,
doubts,
give
sir.
okay and you can give okay and see the result, and you can look at the p value, you can do all that.
Sure, I can help with this. First,
So all of you are able to understand, right? See here in the statistics followed two methods. One is normal approximation method, another one is Fisher test method. A different method gives different p value. It's quite obvious. So normal approximation gives 0.08 and Fisher test gives 0.10. In any case, both of them are above 0.05. If both of them are above 0.05, fail to reject the null. Fail to reject the null means both components have equal conversion rate. Even though numerically there is a difference, I still don't want to conclude and say campaign 2 is better. It's not the right time. But if Naveen could repeat the samples, let's say instead of 1,000, he sent 10,000 mails, and out of 10,000 also he sees a similar rate of conversion. Similar rate of conversion means out of 10,000, how many conversion he is supposed to get?
850.
850. See what happens to your p value if you get 850 conversion out of 10,000.
Yeah. Two proportions.
So make the changes only in group B. Now see what happens to the remaining will be same.
Okay. Okay. Yeah, less than 5%.
So now your confidence, you have to wait till the confidence crosses 95%. You have to wait till the confidence crosses 95%. And see, do one more time. Just reduce your sample size to 100 for group B. For 100, you change. Now we made it 1,000 to 10,000. Now you change it. Reduce it to 100. 100. And you mark 9 conversion. It looks like 9%, isn't it?
Yes.
But is it very riskier? You know why? Because they got 6.5% conversion out of 1,000 events.
1,000.
But now with 100 events, you are getting 9 conversion. Doesn't mean your campaign is better. You see what happens to your p value. Give okay.
Oh, above 5,
So
30%.
so fundamentally what p-value is telling you, the amount of risk involved in your decision. As the trials increases, if there is a consistency in your findings, are you getting it? If you increase the number of trials and you consistently see success, then your confidence level goes high. Then your alpha risk goes low. The amount of alpha risk is given as p-value. If the p-value is below 5%, then you can reject the null. Then you can make a conclusion. Clear?
Yes.
Well done. So Naveen understood how to perform the two proportion test using Minitab. So all of you should practice like this. It's very important. You do the click yourself and interpret yourself. That's how it is. Thank you. You can stop sharing. Now I will share. I will take you through. Okay. You see, there is what is this? Sample 1 proportion 0.04. You know what is 0.04, right? 4%. Sample 2 proportion 9%. Let's say machine 1 and machine 2. Machine 1 produces 4% rejection. Machine 2 produces 9% rejection. Does it mean machine is one of the root cause? Because rejection rate is proportion. Do you all agree? Rejection rate is a proportion. Yes or no? 4%, 9%. Is it a proportion or not?
Yes.
Proportion is a ratio between two attribute data, not a measurable data. 4 parts rejected out of 100, that is 4% proportion. 9 parts rejected out of 100, that is 9% rejection. Now the difference is 0.05. For the same situation, the p-value is 0.018. What do you understand out of the p-value now? Since p-value is less than 5%, you have to reject the
Rejecting
null
null
hypothesis.
hypothesis.
Yeah, rejecting null hypothesis means
There
you
is
can
an
now
Alternate
confidently
hypothesis.
say, machine 2 produces significantly more
Significant.
defects. You can discriminate machines, you can discriminate your suppliers, you can discriminate your team members, for the proportion or the percentage. Whenever you are expressing something in percentage, the scenario leads to proportion test. Are you with me, all of you? It is not a measurable characteristic. Measurable characteristics means it should have been test of averages, particularly two sample test. But since it is attribute, we call it two proportion test. So visual interpretation. Service industry, you see here, there are day shift 500 calls, night shift 400 calls. Out of 500 calls, 20 customer complaints came. Night shift, out of 400 calls, 36 complaints came. Now, our common sense says, yes, shift is a problem, isn't it? So, night shift people don't attend to the calls properly. And so the complaint rate is higher. Can I put this under the two proportion test? Yes or no? Definitely.
Yes.
I can definitely put it under two proportion test and look at the p-value. P-value is how much?
0.03.
So what do you understand? If it is 0.003, below 5%. So night shift
Reject
has
null.
significantly higher compliance. You have to do something, with the night shift. So before taking action, just do this exercise, look at the p-value and then proceed so that, it is good for you to make the right, only the needed changes. You should never be making an unneeded or unwanted change, isn't it? So whether the change is wanted or not, you can actually judge by comparing with the p-value. If you don't have the approach of using p-value, still you can be correct, but the chance of you going wrong may be higher. Do you understand? Do you understand the difference in my statement? I'm not saying that you are always wrong. When you look at a number, when you look at a difference in the number, and the difference can be true, and then you can take action. You can be correct, but the risk involved in your decision can be higher if you don't use statistics. If you use statistics, the risk is also projected side by side, isn't it? Tell me what is the risk involved here? What percentage of risk you are running here? Not even
Not
1%.
even 1%.
Not even. It's 0.3% risk you are running. That means your confidence is 99.97. Normal practice is you should at least achieve a confidence of 95%. So, statistically also you are correct. Your subject knowledge, your experience, your engineering law knowledge, the logic and everything is correct. One more approach to be added. Your decision should also be statistically correct. Right? Even after applying statistics, still you see how much risk we are running. We are running point. We will never be 100% accurate in our decision. Still, little risk will anyway be there. In statistics, it's a normal practice to accept a risk of what? 5%. Oh God. Do you understand, all of you, what is two proportion test?
Yes.
Correct? Now I want you to understand another kind of test called as chi-square test. In chi-square, we again check whether two categorical variables. See, attribute is sometimes called as categorical variable. Like we categorize the outcome into good, bad, pass, fail, okay, not okay. And in chi-square test, there are certain terminology involved: observed frequency and expected frequency. We'll see all those things with an example. See here, we have machine A, machine B, machine C, and machine A produced 200 parts, machine B also produced 200 parts, machine C also produced 200 parts. And normally, defects are expected to be evenly distributed. That is our normal assumption. Yes or no, all of you? If I use 3 machines and produce, and my expectation is since all 3 machines are same, the defects will also be distributed same. 5% means it is 5% everywhere. But sometimes in reality it can differ. So in chi-square there is a formula. You see here, observed frequency minus expected frequency. The difference between observed frequency and expected frequency must be squared, and then we have to divide it by the expected value. And let's see that in a example case, it become much easier. So in a chi-square test, the null hypothesis is the variables are independent. Variables are independent means there is no relationship. But alternate hypothesis, the variables are dependent. Like the machine influence the defect occurrence. If p-value goes below 5%, then alternate will become valid. If it remains more than 5%, then null will be retained as valid. And see here, machine 1, machine 2, machine 3. Machine A, 180 parts produced, 20 defects observed. Machine B, 170 parts produced, and 30 defects. And 190 parts produced, 10 defects. Now, what do you think, all of you, according to your engineering logic or the experience logic? Is there a difference in the defect rate between the machines? Machine type and defect rate, is there a relationship? Yes or no?
As per numerical data, there is a difference, sir.
As per numerical data, there is a thing. That means you doubt that machine type and defect rate are related. Yes or no?
Sir.
If you produce using machine probably A or B, probably, yes. Probably if you use machine B, you will certainly expect more defects. This is what we see in the data. Is this true or not? If you think machine type and defect rate are related, then it is alternate. If machine type and defect rate are not related, there is no relation, then it is null. Are you with me, all of you, in writing the null and alternate?
Yes.
And I also don't want you to do all these calculations manually because Minitab is anyway going to do it. But still, for knowledge sake, I'm showing you some steps. So totally, yes.
540 out of 600.
Okay. Okay, 540 parts only, not, I think it is mentioned as 600 here. Anyway, approximately. Okay, so how to do this in Minitab? Okay, so this is shift versus defect type, morning scratch, shift versus defect type. Okay, so let's take this. Yeah. See
so
here,
that
this
part
is
should be, sorry. So
Hmm.
that part should be 600 only, right?
Yeah, correct. Six, no. See, actually, in this here, this is coming to total is coming to only 540 only.
We
But
have to
that
No,
includes
sir.
take the
defect
Good
defect
as
as
part
well,
well.
is
right?
540.
We have to
Good
take
Ah,
the
part is
defect,
defect also.
540. Total part
Yeah,
600.
correct. Yeah, defect is 600. Yeah, total parts is 600 and defect is 60. Correct. Yeah, the summary is also correct only. So now these are in Minitab, all these steps will be performed automatically. You can go to Minitab, you can go to stat, you can select the table and you can choose the chi-square test and you can enter the contingency table. And then if you click OK, the result will be out. Then you just have to look at p-value and make a decision. But before doing that, let's understand what actually happens inside. Some manual steps, let's understand. Step one is you have to write the hypothesis. Shift and defect type are independent because here the data given is shift, morning shift, afternoon shift, night shift. And the type of defect, scratch 50 observed, dent 30 observed. And similarly, afternoon shift, scratch is 40, dent is 20. Night shift, scratch is 30 and dent is 20. So total number of scratches is 120, dent is 60, 180. Dent is 60 and the total number of parts is 180. And now, yeah. What is this? Morning shift. Yeah. See here, there is a formula for calculating the expected value. What is the formula says? Row total
Total into column total divided by
by
grand total.
Grand total is how much?
180.
600.
180.
600.
Row total for morning shift.
80.
Morning shift
80.
is 80. And under scratch, morning shift under scratch, the column total is
120.
120. So 80 into 120 divided by 180. How much it is coming? 80 into 120 divided by 180. How much it is coming? All of you, please do a small check.
Correct.
Into 120.
53
It is
around.
coming as 53.33. Are you getting it, all of you?
Yes, sir.
This is the formula for calculating the expected value. In the same manner, please do try it for morning shift dent also. For morning shift dent, what is the row total? What is the row total?
80. 80.
30 into 80
Morning shift dent
divided
row
by
total is
180.
80, column total is
60.
60. Grand total is 180. If you
180.
do this, you will get 26.67. Now, can one of you explain how this 13.33 is calculated? $13.33 is applicable for what? Day shift or afternoon shift or night shift?
Night shift.
Night shift dent. The expected number of dents for night shift is row total 40, column total 60 divided by 180. So these are the number of defect scratches expected in morning shift. What is the second one? Afternoon and then the night. Number of dens expected in the morning, afternoon, night shift is here. Are you clear with the expected values, all of you?
Yes, sir.
What is the formula we use? Row total into column total divided by
Grand total.
Grand total.
grand total. But we have to first develop a tabular column like this. This is called the contingency table. This is called contingency table. We have to develop this table, then only we understand what is row total, what is column total, and what is grand total. Now there are certain steps we have completed here. Step number 1, step number 2 we completed. Now let's go to step number 3. Okay. So step the same thing. Yeah. Here is step 3. See here, chi-square calculation. What is chi-square calculation? This is a symbol for chi-square. What is written here? Summation of
Observed minus expected, the whole
minus
square divided by
expected
expected.
frequency. The observed morning scratch, morning dent. Afternoon scratch, afternoon dent. Evening scratch or night scratch, night dent. The values are available here, right? Morning scratch observed is how much?
53.33.
You see here, morning scratch 50. But expected is how much?
53.33.
53.33. In this manner, you now have to create another table. Why? So that you can actually calculate O minus E. What is O minus E? Observed frequency minus expected frequency. So 50 minus 53.33 will be minus 3.33. But according to the formula, we have to square this. Can you do this parallelly? Minus 3.33. This must be squared, right? This must be squared. And afterwards, we have to divide this by
53.33. 53.33.
So what is the value we are getting?
0.2079.
Very good. 0.2079, but it is rounded as 0.21. Nothing wrong in it. 0.7 is considered as
round.
Greater than 5. Yes.
0.21.
Yeah, that is okay. So in that manner, we can calculate the chi-square value for every row in the table. Are you with me, all of you?
Yes.
Yes, sir.
Yes. Now the chi-square must be summed up. Total chi-square. How much it is?
1.88.
1.88. Now we have something called degree of freedom. Degree of freedom, you go back to your contingency table. How many rows are there? How many rows are there?
3.
3 rows. Because you have morning shift, you have afternoon shift, you have evening shift. Night shift. And similarly, type of defects, how many you have?
2.
Scratch
and dent.
Dent.
2.
So there are 3 rows and 2 columns. So formula for degree of freedom is 3 minus row minus 1 into column minus 1. 3 minus 1 into 2 minus 1. Do you understand? So the degree of freedom is 2. The chi-square value is 1.88. There is a standard table available, and from the standard table, for a degree of freedom of 2, chi-square value of 5.99 is found. But our chi-square is found to be lower than the critical value. Do you see that, all of you? Our calculated chi-square, is it more than the tabulated chi-square called the critical value, or our chi-square is more or less?
Less, sir.
Whenever it is less, fail to reject the null. Fail to reject the null. Fail to reject the null means you accept the null. But we don't do all this manual calculation in any of the hypothesis test. Instead, what we do is we look at the p-value. So I'm showing you a Minitab output. Instead of doing all these steps manually, I want you to just prepare a table like this. What is this table called? Contingency table. Once will you be able to prepare this table based on the information made available to you?
Yes.
Yes, we can make this table available. And actually, this is output. The contingency table is here. This is contingency table. So this table we have to prepare, and then if you give the ask the Minitab to perform the test, and look here, the p-value is how much? 0.0.
39.
39. 0.39 means fail to reject the null. That means shift and defect has no relationship. Do you understand, all of you?
Sir, I have one doubt, sir.
If you are doing a project, if you think defects are more only in the night shift, you have to prove that your assumption. If your assumption is yes, so night shift only defects are changing, so don't produce that part in the night shift. If you really wanted to make such changes, then you should prove it with the chi-square test. If you are not able to prove it, then we will not be in a position to accept your suggestion. Yeah, what's your question now?
Sir, but there is a opportunity for the improvement, sir. But numerical data also shows that. But this concept remains the same, sir. This concept gives there is no difference. Do you
See,
understand,
the
sir?
statistics is telling you something, and finally, what is finally, your common sense, See, your accountability is more important than anything else. Yes or no?
Yes, sir.
See, this is like integrating a statistical approach in your decision. If you don't want to integrate, you want to proceed with mere observation. It's up to you. I already told you what actually statistics does, isn't it? See, how many days you observed your process? See here, morning shift, scratches 50 and dent 30. How many days you observed this? Some assumption. Let us say, you got this
One
in
day.
1 day only, right? One
One
day
day.
only.
Yes.
If you observe one more day, can the number be same?
No, sir. There will be a difference.
Then why do you want to completely confine your thinking to the numbers on the screen? Are you getting it?
No, sir. Just I got the doubt, sir. That's why I asked.
No. See, your doubt is correct, but still, see, if you say, sir, I will also use the p-value while making the decisions and inferences, I will definitely look at the p-value. Then you are perfectly all right. You are not only looking at the numbers, you are also statistically correct, right? But sometimes completely going with your common sense, may be meaningful. In those scenarios, you proceed. Okay. All right. Now let's see how can we do this in Minitab. So let us go to the worksheet. Okay. One is shift right. So what are the options available? Morning,
Afternoon,
and then night shift. And then there is scratch. Do you remember the numbers? 50, 50, 40, 30, right? So 50, 40, 30. Then how many tenth? I'll show you.
30,
How many
20,
tenth?
10.
30, 20, 10. Very good. 30, 20, 10. Now the contingency table is ready. Now we just have to go to stat, go to table, go to cross tabulation and chi-square. Summarize and count data for groups that are formed by 2 or more categorical variable. Click. Now you have raw data or you have summarized the data. I have summarized the data. Columns containing the table. Columns containing the table, there is scratch and there is dent. There is a scratch and there is dent.
Shift
So
is not reflecting, sir.
1 minute. Okay. Columns with the row label. Label for the table. Names for column category. Types. Yes, it is not reflecting. 1 minute. So let us go to the chi-square test and then enable the chi-square test. Then you give OK. Then you give one more OK. And now all done. The p-value has come. Yes. And here, 1, 2, 3, it is considered as 1, 2, 3. Whereas the 1 is your day shift, 2 is your afternoon shift, and then 3 is your night shift. And the result is under obtained. Is it clear to all of you? Now let's see whether we can somehow bring in that first column shift. So stat table, cross table, and chi-square. Everything is done. Labels for the table, row label, name for column category. That is there. Column with the row label. Write out. Here, if I give the shift, it has come. Can you see here, all of you? Are you seeing it? Who asked this question?
Yes, sir.
So if you want the 1, 2, 3 to be replaced by your, what do you call? For every column information, you also wanted the shift, So for that, you just have to include that column as well. Table, chi-square test, and see what I did. You have to, it's association. Stat, table, this one, cross tabulation and chi-square. You see here, in this area, you can give your row label. The row label in the sense for every column, which shift it is coming under. So that information can be, you can insert it here and then you can proceed. Okay, clear? Can Naveen, can you again do this for our candidates and then we can wind up test for test?
Yeah, sure, sir. Let me
Just
share.
quickly do it in 2 minutes so that all of us, will gain some confidence that we can also do it. See, manual procedures are also there. And like I explained, but you no need to remember all those things, but there are some methods. If needed, you can deep dive and understand. So just type shift. Yes, it is morning, afternoon, and night. And it is 50. This is a scratch, a dent. How much it is? 50, 40, 30. Yeah. Yes.
Just give
40.
it.
50. Yes, you're right. 50, 40, 30. Then 30,
20, 10.
20, 10. 30, 20, 10. And now you can do it. Stat, go to tables.
Tables,
Cross
tabulation,
tabulation.
and
Change
select
it
here
to
Summarize.
table.
enter.
Then have your columns. Yes, click there. Click
Double,
there.
double,
No, you have to click.
double click.
Click there. You put your cursor there. It's not showing.
No.
I see a problem. You cancel this. Cancel this. Cancel this. You see where have you typed your column labels?
Yes.
You shift the column first. No, take only the column. Sorry, first row only. First row. Shift, scratch, and dent. You copy. Put it on C4. Control X. Place your cursor on C4. C4. Go to C4 because still the T is continuing. Can you see that? So don't
Okay.
use that place. Come to C4. And now copy all the data. Put it under C4, C5, C6. And now there is a problem. See, here problem is only with C5 and C6. Can you remove the data? 50 numbers, all the numbers, please. Remove the data. Remove that. Now C4, you retype it. 50, 40, 30.
C4.
No,
Yeah.
under C5. No, that can remove. That can remain. Let the the shift continue. Morning.
Okay.
Because under scratch, we need only numbers. Now you type 50, 40, 30.
40, 30.
Okay. And for 30, 20, 10. Now you do the
This T
analysis
is okay?
with this. That is okay because that is only containing text, So that is
Okay,
okay.
okay.
If it is a numerical data, then you should be careful
Yeah.
how this will work. Summary.
Yeah,
Now
okay.
C5, C6, you can select C5, C6.
If
Click
Where
select
put
or
in?
double click. No, double click or click select.
Yes.
Now under rows, you can select the shift and go chi-square. Yeah, enable the chi-square. So it will calculate all the formulas we know, but we are making Minitab to do it for us. And
Yeah, that's right.
And can you also go to ChatGPT? Select this first, shift scratch dent data. Please copy this. Copy this. Yeah, copy this. Yeah. Go to ChatGPT.
I don't have ChatGPT, sir. Like
Okay.
Copilot, is that okay?
Okay. Try. See, but no, you study the AI. If that works well for you, then you can use it. Copilot also use it. See whether Copilot has
Yeah.
that capability. And you ask the Copilot to do the chi-square test. Let's see. Allow this time. Okay. Just paste that data and ask your co-pilot to perform chi-square test. Let's see what it does. If it does, it is asking you to do a lot.
Yeah. It's my office computer.
Okay. No problem.
Yes.
Perform chi-square test for the below data.
Is it doing it? But my ChatGPT did the job. Oh, you are getting it? Very nice. Excellent. So, all of you, please understand now, there is no limit. Nothing can, act as a barrier nowadays because the knowledge is, available in an excellent format. Only thing is we should know how to use that knowledge. Yes or no?
Oh, yes.
Even if you do not know what is chi-square test, then you are still able to do chi-square test. Yes or no?
Yes.
But if you also know what is a chi-square test and when to use it, how to use it, and there is some tool available which can do the chi-square test for you, what is stopping you from using it? So use it for your betterment. So that's it from me for the day, and we'll meet in the next class. Okay.
Thank you, sir.
Yes.
So
Thank you,
today's
sir.
class
Thank you.
is helpful.
Thank you.
Yes, very
Yes.
helpful.
Yes, sir.